Hey there, folks, and welcome to today's episode of Into the Terminal. I'm your host, Nate, and today I'm flying solo because Scott double booked his appointment with the recovering administrators that like to use servers with GUI support groups. So, I'm going to apologize in advance for if I can't get to chat or whatever. I'm going to try to monitor everything as things go. But today, we're going to be talking about one of my favorite topics, apart from RHEL security, which maybe you've noticed I like to talk about, and that's containers on Linux. Now, I've talked about Podman in the past on this show. I've talked about Podman and a lot of other live streams and whatnot that we have done. But today, I'm going to be showing you how I run services in Podman, both in my home lab and even on my personal websites and things that I run in quasi production mode. So let's go ahead and hop right on into the terminal, and we're going to show you how I like to run services in Podman. We're going to start with some basics. There we go. There's my terminal. Okay, so first of all, I like to use a feature of Podman called pods. So we're going to start with some basics and show you how to make a pod and how to put a container in that pod. And then later in the episode, we're going to talk a little more in depth about why I like pods and basically what's going on with a pod versus just running a container sort of bare within Podman. So first, we're going to start by making a pod. Let me just grab my command here so that I can not typo stuff for you guys. Okay, so Podman pod create, and then dash dash name tells it what do we want to call the pod, right? So we're going to call it test HTTP. And then at the pod level, we're going to tell it what ports to publish, right? Now, normally when you start a container, you say publish these ports. Maybe you say publish these ports on these IP addresses. But in this case, we're going to do that at the pod level. And I'll talk more about why that is in a little bit. But we're going to publish port 80 and port 443. So you can guess what we're going to put inside of this pod. So here we're going to run that. And it's going to give us just this pretty generic output. It gives us an ID of what was sort of assigned to that thing within Podman. Now we're going to put a container inside of that pod. And as you might have guessed, that container is going to be HTTPD. So give me just a sec here. We're going to copy and paste this over here so we don't typo anything. All right, so Podman run. This tells it to basically go get a container image and run it. We're gonna give it. We're gonna tell it to run it within the test HTTP pod. We're gonna give it a name called app, which is of course very generic. I'll explain why I'm using such shortened names in a little bit when we talk about some of the more advanced features here. Dash D tells it to run sort of detached or in the background, and we're gonna just pull a container image directly from Docker Hub, as you might expect. So the docker.io HTTPD latest. Okay, now I've already pulled this container in the past while setting up for today's lab. So normally you would see it, of course, pulling down the container and whatnot. Okay, so nothing real fancy has happened here at this point. Nothing that you can see on the screen, obviously. But we're going to go and we're going to check and see what Podman says about what's running. So if we do a Podman PS, you see there's actually two containers running. And I've talked about this in the past. Basically, when you make a pod, there's an infrastructure pod or infrastructure container that runs that sort of encapsulates your other containers within that pod. So that's why we have two here, right? You see there's the HTTPD pod or container that we just created, and then there's this infrastructure container. Now, if I did a Podman pod PS, you'll see we just have a single pod running called test HTTP. And within that, of course, is running our HTTP container. Now, you might say, well, is it working? Give me just a second here. Somewhere I've got another browser window that I can show you that it's working in. Let me switch my share. Over to this guy. Now you can see right there, I opened up this browser tab before I started the container running. So of course it says it can't reach anything. If I reload this, we should get the it works page right out of Apache. So there we go. That's the generic Apache. Hey, look, you've got something running within your Apache configuration. So let me switch back to my terminal here. 'cause I got a few more things to show you before we go into the deeper dive. Okay, so some of the things I like about pods is that, and like I said, we're going to go a little deeper on this in just a minute. Some of the things I like about pods is that it takes all of the containers for a service and sort of containerizes the containers, right? And it lets you do cool things like I can check the status of an entire application by looking at this particular Podman PS output. It says that it's running. If there were 5 or 6 containers running within this pod and 1 or 2 of them was down, this would tell me right here that it's degraded. And right here it would say I have less than the optimal number of containers running. If I know there should be 5 containers, for example, and it says there's 3 running, then I know something's not running right. And then of course I can use Podman PS to look and see what containers are running and see what's not up. But the other cool thing is it'll take the log output or the console output of all of those containers and put it inside of a Podman log output. So if I do a Podman pod logs on test HTTP or HTTP, it'll give me the output of any container that's running within that pod right there in that one command. So if I had, say, a database and a web server, or like a database, a web server, and a, I don't know, message queue or something all running, if any one of them is outputting errors, I'll see it right inside of this pod logs output, right? So I think that's pretty helpful. The other cool thing is you can start and stop an entire service by starting and stopping the pod. Right, so I do this, and now if I do a Podman pod PS again, you'll see I have a pod called test HTTP, and it says that it's exited, which tells me that not only is it not running, but it's because I told it to exit it, right? If you define a pod and it doesn't start, or if, say, you have this pod defined and your server reboots or something, it'll say, instead of exited, it'll just say created, right? And I think there's another status for if it had died abnormally. All right, let's see. Let's start it back up again. So you can just do a pod start and then HTTP, and it starts the whole thing back up again. Again, this is like pretty common stuff, but again, critical path, we're going to go a little deeper in a minute. And then of course, well, I already showed you pod logs, but if I showed you that again, you're going to see the startup output from HTTPD. My screen share died. How long has that not been working? Sorry, folks. Do you still see my screen share? It says I don't have a screen share. Huh. All right, give me a sec here. Why'd my screen share go away? There we go. All right, so there's the log output that I was talking about a minute ago. You can see that it shows me the startup output for HTTPD, right? So good stuff. All right, so I know I just got the screen share fixed, but okay, you do still see it. I don't know why it wasn't showing it on my end. Well, anyway. All right, folks. So stick around because we're going to talk a little bit more in depth about pods and how they work, and we're going to show a little bit more about how I like to take those pods and make them repeatable, easily repeatable. Okay, and there's a couple steps to that as well, and there might even be some whiteboarding, even though Scott's not here. So stick around. After the break, we're going to be talking about all of those things. Remember, if you like this kind of content, make sure to like and subscribe. And yeah, we're here every Friday, roughly, and I'll catch you after the break. All right, so welcome back. Thanks for sticking around. Like I said, I'm doing like all the producery things all at once, and sorry if there's any gaps here. But so Podman pods, I like to put anything that I deploy, even if it's a single container, like I just showed in the critical path, into a pod. And the reason I do that is because it adds some uniformity to how I run Podman. Now, if you're running a service that only uses one container, I don't know that there's a huge technical reason that you might want to put it inside of a pod. I do it because that means that whenever I'm managing an application, I'm managing them all in the same way. I manage it through pods, even if it's one container or 20 containers. I always know there's a pod that I can use to manage the thing. And another reason that I do that is because, and I'm going to show you in a minute, it makes it easier to make them redeployable, and it makes them easier to manage with Quadlet. So that's going to be our last demo for today. So what I want to do is just looking at the chat here. Okay, so some people are saying my screen share did not go away, but it did. I don't know why it went away on my side. But anyway, we're going to get back into another screen share in just a second. So we made that pod during the critical path, and we're going to work with it a little bit more. Let me clear my screen. There's features of Podman called Podman Play and Podman Generate. And these two subcommands of Podman will let you do things like, I've got a container, I want to make a systemd unit file out of it. You do Podman Generate systemd, and it'll output a unit file for your for whatever it is that you called from within Podman. But what I'm going to show you today is Podman Play and Podman Generate kube, right? So first of all, we're going to Podman pods stop test HTTP. You don't have to stop it to use Podman Generate, but I'm going to delete it in a minute, and I'd rather have it stopped if I'm going to delete it. So if I do now Podman Generate kube test HTTP, it's going to output to the screen a YAML definition, which is very similar to what you might use in like a Kubernetes infrastructure to deploy a pod like this. Now, I have tried to take these deployments and put them directly into Kubernetes, and I'm going to tell you that there are pieces, there's like more advanced features in Kubernetes which are not included in these definitions, but it's a start, right? It gets you the container image. It'll output things like volume mappings and stuff that you have in place. But it doesn't give you, it's not just grab this and put it into Kubernetes, at least not in my experience. I'm not a huge Kubernetes admin, so if someone's in the chat that they're like, oh no, they're totally portable, please go ahead, say so, and I'll correct myself. I don't mind being corrected on the air. But obviously, outputting to the screen isn't terribly useful. So what I'm going to do is I'm going to redirect this into a file, and we're just going to call it test http pod.yml, right? It's a YAML file. Now, if I cat this file out, it's the exact same output that we just saw when I ran the command all by itself. So let's clear the screen again. The cool thing about this is now if I pod rm test http and then do a podman pod ps, you're going to see here, YAML is never the solution to anything. Yes, thank you, Shantanu. Now you're going to see there's no more pods defined. So what I'm going to do is, actually, there is one thing I want to show you before I redeploy this. Remember when I named that container just app, right? And here it says that the container name is app. There's also up here in the pod definition, there's a label that gives it a name for the pod, right? Now, this is going to make a lot more sense in just a minute. Hold on. If I do a podman play kube, and then I point it to this file, what it's going to do is it's going to read in that YAML, and it's going to redeploy my pod using that YAML definition. If I do a podman pod ps, now we've got test HTTP back. It's already up and running. I think there's commands that you can use that'll tell it to define it without running it, things like that. But that's not what I did in this case. But here you are, right? It's up and running again. Now, if I do a podman ps, we're going to notice something interesting about the name of our container that opened up within our pod. And that is test HTTP app. What it does is it takes the name of the pod and the name of the container and munges it together like this. It goes test HTTP, that's the name of the pod, dash, and then the name of the container. So if I were to call my container test HTTP within the pod test HTTP, then the container name would be test HTTP dash test HTTP, which would get really redundant. So that's why when I'm trying to manually make a pod that I'm then going to export, I know I'm going to export it in this Kubernetes YAML file, I always make the container names sort of generic, right? So if I'm deploying any application, the front-end application I'll usually just call app, or you could call it web or call it front end, something like that. The database, I'll always call DB or Postgres or Maria, right? Depending on what it is that's underneath there. If there's a Redis queue in there, I'll call it Redis instead of whatever dash Redis. And then when I redeploy it using this Podman play, it'll give it a name that's more like WordPress -DB, right? If WordPress was the name of my pod and DB was the name of the database container, it's a little easier to read, right? So that's just a thing that you want to kind of be aware of. Okay, so now I could take you back over to my web browser and show you that this is up and running, but I'm just going to ask you to trust me on that because I don't feel like switching my shares around again, because I'm going to have to switch them again in just a second anyway, because now it's whiteboard time. So give me just a moment here, make sure my whiteboard share is going to work like I want it to. Window, here we go. No, that's not the right window. Where is the window? Here it is. Okay. Too many windows open, guys. All right, so here we go. I got my pencil here, and we're gonna whiteboard something. This is all about pods and why I like them so much. Okay, so remember when we deployed, so when you deploy a container, right? So now imagine that this line here is like the network stack within your container host, okay? So just imagine, right? So, you know, you've got an IP address on here. I don't know, we'll just 10.0.0.1 as an example, even though that's not the IP address of our host, right? So that's the IP that the network sees. When you deploy a container, let me use a different color for my container here. When you deploy a new container, let's put that, what did I do here? There. When you deploy a new container, you tell it map a certain port. Maybe that's 80. So you map port 80 to port 80, right? Terrible handwriting, sorry. And what that tells Podman or your container daemon is, or container runtime, is any requests that come in to this IP for port 80 should go through the network stack and to this container, right? Now, that's fine if you have a single application, because like I said, if you're running, like I don't see a huge technical benefit to running a single container in a pod because of this reason. But if you have, say this is a web server, and along with that web server, you need a database, right? So let's just say your database, we'll just pick the MariaDB port, listens on 3306, right? Now you need to tell it to map port 3306 into this container from here. And that means that anything on this system, because you've mapped port 3306, will go through your network stack and into port 3306. Or if you were maybe a little too lazy and didn't specify in your network firewall that port 3306 shouldn't be accessible to the world, now things from the outside can try to hit 3306 as well. Okay? So that's kind of like just raw containers, how container networking works. Now, there are concepts of things like container networks, and that's another way to solve this problem. And that's what I did when I was running things in the Docker days. But what I like to do now is, instead of messing around with container networks, what I'll do, just imagine the same scenario here. We've got your host's network, right? And again, we've got 10.0.0.1, just say. All right, now, when I define a pod, what that pod is doing, let's pick another color for pods. What that pod is doing is it makes sort of like a big container that little containers can run inside of, right? And let's just say, like, this one is web and this one is database, and I don't know, this one is something else like Redis or something. Now, at the pod level, I tell it, let's map in port 80, but only port 80, nothing else. So now when a request comes in to my system for port 80, it goes in, so, oh, look, 80, and it sends it here. Now, you might say, how does it know what container to send it to? That is basically whichever container within the pod is listening on port 80, that's where the request gets routed to. Now, I don't know if there's a more advanced way to do that. Like, what if there's more than one container in here listening on 80? That sounds like bad pod design to me, but whatever. Now, obviously, your database probably still has 3306 open, and Redis has, I don't know, whatever Redis port is. I don't know that off the top of my head. The cool thing about this, and this is the whole point of why I showed you this diagram, is within this pod, if I tell my web host, my web container, to connect to DB colon 3306, assuming that I called, or WordPress DB, or whatever I called my DB container, it won't leave the pod. It'll just go right over to that container. Same thing if my web tries to talk to my Redis host, my Redis container. It stays within the pod. I've never opened these ports out to the world. Nobody can get to those, even from my Docker host, or my Podman host, sorry, slip there. Even from my Podman host, they can't reach either the Redis or the database. Now, obviously, you can do it through Podman commands like Podman exec, Podman shell, that kind of thing. But I mean, from a network perspective, the only way to get to those containers is from within the pod. A cool way to troubleshoot at that point is you can like make a new container within the pod that runs like a UBI shell or something, and then you can talk to those other containers within the pod. But that's sort of like more advanced troubleshooting stuff. So there's the reason, right? That's why I like pods so much. Another reason I like to put even single applications within a pod is if for some reason in the future that application expands for some reason, like all of a sudden now it needs a database, or all of a sudden now it needs, a message queue, or I don't know, whatever, right? This way I can just add that into the container pod, and there you go. We've got the pod up and running, or we've got the pod, and then we've got the supporting service, and they're still nicely sort of cordoned off from all the other containers. The other cool thing is, I normally, if I'm running several web containers on a host, I will have something that's managing ingress. Right now, in like a big Kubernetes world, you'd have like an ingress controller. I just use a reverse proxy like Nginx. If I'm running a dozen web containers on a machine, I'll have all of those in pods, and I'll have different ports mapped in on the host, and then I'll have Nginx reverse proxy to all of those individual services, right? And each one of those might have its own database and have its own web front end, and each one of those is cordoned off from all the other ones. So if one of those were say compromised or something, it's a lot more difficult for someone to get across inside of my host to another one of my containers, except maybe another container that's within that pod. So it's just one more thing, one more layer of defense that I like to run from within my pods. Okay, let me look at chat quick, see if anybody has any Podman questions in here. I don't think I see any. Pods share the same network namespace. Yes, that's true. Thank you. Container on the same pod share the same network namespace. Yeah. So there's basically like internal DNS also that runs within there. That's why I was saying that you could call other containers by name, right? So that's actually really handy. You can just in your definition, and I'm going to show that to you in my next example here as well. So that'll be coming up in just a second here. So let me look here. Oh, that's what I wanted to show you next. There's another cool thing. If you've ever managed containers, you notice that there's a lot of cases where you're passing in environment variables to tell the container how to, say, get to its database, right? Or where to find certain things, or just basically configuration for the web application is done through environment variables. Now, like it or hate it, that's the way it's pretty commonly done. So we're going to switch back to let's see if the share switches back. There we go. Back to my container host here. A way that I like to do that. Now, you can define environment within that Kubernetes or kube YAML file. And that's obviously one way to do it. And it's especially useful if you have things that are specific to each container, right? But in some cases, you've got those environment variables that you want to share across several containers within a pod. And for that, I like to use a config map. And believe it or not, Podman supports config maps. There's just like a command line argument that lets you use a config map. And if you're not familiar with a config map, well, I'm going to show you what config maps are. First of all, I wanted to share that I have the stuff I'm going to use in this next demo published on a GitLab instance that I run. So if you want to go check it out, I just put it up on the screen. Sorry for the very difficult to, um, what's the word I'm looking for? Digest URL, because that's like my personal domain that I use for stuff. I've owned it for years and years and years. And yes, it's underground is intentionally missing a letter. That's because true underground was taken. And that was how I got the domain I wanted. Okay, so let me go to where I've got this copied to. We're going to deploy WordPress using Podman Pods with a config map and this Kubernetes definition that I've got right here, or kube file, and we're eventually going to use Quadlet to make this thing run underneath systemd. So bear with me here. First, I want to show you the config map. Now, there are some caveats with this config map that I've never been able to figure out exactly how to do. So when you deploy WordPress and MariaDB, you pass in environment variables that tell MariaDB, what's my root password? What is my database? What is the username and password that you want to set for that database when it's created? And those are these things here, these MariaDB root password, MariaDB database, MariaDB user, and MariaDB password. These are environment variables. I'm doing them in a config map here because I think it's a lot easier to manage. Now, the thing that I wish I knew how to do, and I have tried several times to figure out how to do this, is how do I tell my config map that my WordPress DB name, my WordPress DB user, and my WordPress DB password are just copies of the MariaDB password, MariaDB user, and MariaDB database. I've tried several ways to like interpolate those, and I just can't get it to work. So if someone in the chat knows how to do that, please tell me, because this is repetition of data, and it's really easy to say like, when I put the password in, the MariaDB password and the WordPress DB password, maybe I typoed one or the other, and then it just leads to headaches later, which is kind of annoying. So, but anyway, back on point here. What I've got here is these are the environment variables that are going to be passed into my containers within the pod using a config map. Okay, and this again, right, it's just another YAML file. You can look up what a Kubernetes config map looks like, and that's exactly what you're going to the format you're going to have to put this in. Let me look at chat and see if somebody's answering my question. Doesn't look that way. YAML star and I don't know if that's what I'm talking about. Anyway, all right, so that's the config map. What we're going to do is we are going to show you how we run. Actually, first let me get rid of test HTTP because it's going to use the same ports we're going to use here. Okay, and we're going to clear the screen. Now we're going to use Podman Play to run this WordPress deployment. Here, let me get this off the screen here so we're not blocking any output. Oh, sorry about that. Copy, paste, fail. Copy this and paste it over here. There we go. Okay, so Podman Play kube, right? And then we just have -- config map equals, and then the file that the config map is in. And then after that, we just tell it what is the YAML file that has the pod definition, right? And there we go. We're going to hit enter. And what this is going to do is it's going to read in that pod definition. It's going to add in all those environment variables that were within my config map. And then it's going to make the pod. If I do pod PS now, there you go. We have a WordPress pod up and running. And if I do podman PS, you're going to see within the pod, there's a WordPress-DB and a WordPress-WordPress. See what I mean about that weird repetition of names if you don't name your application in a way that's aware of how these things are going to get deployed. Now, I did want to show you this as well. WordPress-pod we're going to look at. So you might ask, how does the pod get the config map reference? And that's right here. You can see here when I'm defining containers, name, DB, env from instead of env. right? Normally you would just say env, and then there'd be a bunch of key value pairs in here. In this case, I'm saying take the entire config map, and you can do this one by one if you wanted. So say you wanted things like the MariaDB root password to be passed into the MariaDB container, but you don't want the MariaDB root password passed into the WordPress container. You can individually cherry pick environment variables you want to hand in. I did this only for the sake of speediness, right? So config map ref, this passes the entire config map named WordPress env into this container. Tells it it's required, not optional. And then this is the image that I'm running. Did you know that there's a MariaDB UBI container now officially hosted on Docker Hub? I didn't know that until I started preparing for this this demo. So that's pretty cool. I don't have to use like some weird like Debian based or something MariaDB anymore. I can use one that's based on RHEL UBI. That's based on RHEL UBI 9. So pretty cool. Okay. I just want to show you that down here where I do the WordPress container, again, I've got the same env from passed in here with the config map ref. So all of the environment variables that were in that config map are passed into both containers. Like I said, maybe not the best from a security perspective. So maybe you want to cherry pick out, here's my WordPress ones and here's my MariaDB ones. So anyway, just keep that in mind. Okay, now we're going to close out of that. We already deployed this pod. See what I want to show you next. Oh, I'm going to show you that it worked. So let me switch my screen share again. And we're going to share the browser tab. So remember, this is my It Works page out of Apache. Now, everybody cross your fingers. But if I run this again, if I refresh this page, it should give me the WordPress setup screen. And there we go. It's asking me to configure WordPress. So if I hit next, you're going to notice here, normally, if you're familiar with configuring WordPress, you would know the next thing that it would normally ask you for is, where's my database? It didn't ask me any of that because I passed that all in using that config map. And that's why I like those config maps so much, because you can centrally contain all of those environment variables. You have one place to go to modify them all. You don't have to go through the whole YAML definition to find all the variables and make sure that you've swapped in the right ones for the right places. So there we go. There we've got good old WordPress ready to go. Now, there's one more thing I want to show you, and my gosh, I'm actually close to on time. Let's see if I can blow the time out of the water by talking about Quadlets next. So let me switch back to my terminal window here. There we go. Let's clear the screen. All right, we're gonna nuke our WordPress, even though we just created it. That's the other thing I wanted to show you. Another thing that I defined within here is what volumes I needed to map in for persistent storage. WordPress obviously is a stateful application. It's got a database that needs to store data, and it's got the WordPress like themes and user content and all that stuff. Plugins you've installed. Those are all things that need to be persisted between, otherwise if you delete the pod in the container, all that goes away. And then your website, every time you restart it, is going to go back to nothing. And we don't really want that. Shantanu, thank you. Go above time, annoy previous producer Eric. That is our job ever since Eric left the team, to annoy him at every chance we get. So that's exactly what I'll do. All right. So what I was talking about here is, you see these volume mounts that I have defined for each container. So that's the one for the MariaDB container, because that's where MariaDB stores its database files. And then, of course, there's one here for the WordPress WP content, which is where it stores all of its persistent data. And you see it's mapping to these WP content vol and WP DB vol, I think I called the other one. You can make those separate volumes within Kubernetes, or not Kubernetes, I'm sorry. You could make them separate volumes in Kubernetes if you're using it with Kubernetes. You can make those separate volumes within Podman, which is what I do for things that I host in my home lab, because I have a Synology NAS that I use NFS. I make Podman volumes that go directly to NFS for things that I host in my home lab. So for those, what you have to do is you make a volume and you map it to NFS, and then you can call that directly from your container. I think it's really slick. But on the host that I run for production stuff, I don't have NFS at my disposal, so I do it this way. And that is, I just have a local path on the server that I store this data in, right? And then I just named it WP content vol and DB vol so that I could then call it when I instantiated the containers themselves. So it's just another way that this is all encapsulated in one thing. So the cool thing about this is that the Git repo that I shared earlier, if you were to copy that, change the passwords, change the name of the deployment, things like that, change things so that they are yours instead of mine, you could deploy a WordPress website with database just by changing some variables around, and off you go. So, and of course, paths and whatnot. Okay, so on to Quadlet, which is what I was actually about to talk about in this particular demo. You'll notice there's a Quadlet subdirectory inside of this deployment. Now, again, if you looked at that Git repository here, I'll put it on the screen again if anybody missed it before. You look at that Git repository. Inside of there, you'll see there's a subdirectory called Quadlet, and inside of there, there's a file called WordPress-pod.kube. Oops. Typos. See, I should have copy and pasted. Quadlet. You'd think something so simple would be easy to type. WordPress-pod.kube. Okay, and here, let me clean the screen up because that's ugly. All right, so you can tell this looks really similar to a plain old systemd unit file, right? What we have here is, sorry, that got weird because there's no carriage return at the end of my file. It tells it you can define things like what order to bring things up in, just like you would with the systemd unit file. The weird things happen inside of this kube block here. You can see we're calling a YAML file, and it's etc containers systemd WordPress pod. You can put that anywhere. For the sake of portability, in this demo, I'm putting it inside of etc containers systemd because that's where the kube file is going to go. Normally, I would put it wherever I'm storing my container definitions, right? So maybe that's in, /serve, or maybe that's in /container defs, whatever, right? Wherever you're going to put that stuff. Config map, we have to point it to the config map itself, right? So we say the config map is also in etc containers systemd WordPress config map YAML. And then we tell it what port to publish, because systemd has to care about that because it does some network magic when it's deploying this stuff. So we're going to tell it to publish port 80 and map it to port 80. If you were tying this to a specific IP, you would do publish port IP :80:80, and then that would say this system IP gets port 80 mapped to this particular container, right? Okay, so what we're going to do is we're going to put that. Did I delete? Yeah, Podman pod stop. WordPress. No, just WordPress. Then we're going to remove it again. You might ask, why are you removing that? I'm going to show you in a minute. Okay, we're going to completely eradicate it. Now, the cool thing about the systemd Quadlet stuff is we're going to copy Quadlet /WordPress pod cube into /etc containers systemd, and we're going to copy WordPress star.yaml to etc containers systemd. And so that way, that's just so that everything's in the right place. Like I said, I could have said, no, my YAML files are in home Nate WordPress Podman, which is where the stuff lives. But in this case, I'm putting it all inside of there for the sake of portability. Now, just putting them there doesn't actually do anything, except the next time systemd is reloaded, the daemon is reloaded, or the next time you reboot, it's going to read those in, and Quadlet is going to generate systemd unit files for those things. And you can see what it's going to do with a command called dry run from Quadlet. So I'm going to paste this in here. Just realized my Git repo is still blocking part of the screen. Let's get that out of the way. User libexec podman Quadlet -- dry run. What that's going to do is it's going to go and read everything that's in etc containers systemd. And it's going to find the things that are supposed to be Quadlet unit files, and it's going to show you what it's going to generate. Okay. So it's going to read in that unit file that we just defined, and it's going to turn it into a systemd service file, right? So let's see here. I think this is the top of the output. Yeah. WordPress-pod.service is going to be created, and this is what that unit file is going to look like. And there's a couple things I wanted to call out here. One is the exec start. So you see exec start equals user bin podman kube play. They just do it. I do play kube. It does kube play. And then it does this dash dash replace, which basically says take the definition that I'm calling right here. And if there's a pod that already is called that, delete it, make a new one using this definition. And the reason I want to call this out is because that means in order to do updates to this unit file, or not unit file, to this pod, all you need to do is do a systemctl restart on WordPress-pod. What that'll do is it'll stop the containers, it'll stop the pod, and then it'll check, like when it starts it back up again, part of this startup will be go get the latest versions of those containers. And I was trying to cook up a demo that would show that easily, but I just didn't have a good way to show it to you other than going in and changing the YAML, which is another interesting thing. If you go to your WordPress pod.yaml file and make changes in it, and then restart the service, it'll also read in the changes that you put inside of that YAML file. So that's another cool thing. If you're like troubleshooting, or if you want to make a quick change, or if there's a change that's happening to the service, you can stage those changes in that YAML file. Of course, test them in non-production first. And then all you do is restart the service, and it'll reread those config changes and stand that up in the next time the service starts up. Okay, so now we saw what the dry run looks like. We're going to do a systemctl daemon-reload. What that's going to do, it doesn't output anything, but what it's going to do is it's going to generate those service files, and it's going to read them into systemd. So now if I do a systemctl, what is it? List units type equals service, and we're just going to grep for WordPress. You should see, oh, no, I guess not. Either I typoed something or whatever, but there it is. WordPress pod.service is loaded, but it's not active, right? That's because all we did was define it and then do a daemon reload. If I do a systemctl start on WordPress-pod, now obviously these things are, stat, start, forgot the R. Obviously these things are running as root. You can make this stuff work with Podman rootless. There's user drop-in files that systemd will read so that you can do systemctl start as a user. They're all stored within your home directory then. So just keep that in mind. So assuming that I got everything right, and we just ran this thing, so we know that it was working, that pod definition. There it is. It started up. If I do a podman, well, here, let's do a systemctl status on WordPress pod now, and there you go. Now, this output is red. That doesn't actually mean that it's errors. That's just the output from the container. Sometimes systemd or journalctl gets the output and colors it wrong. But you can see it's just like the startup stuff out of Apache and MariaDB. But there you go. It says it's active and it's running. If I do a podman pod ps, you'll see we have a WordPress pod up and running. If I do a ps-a, you can see we've got WordPress DB and WordPress up and running. You've got that infra, and I think a service one also comes from Quadlet, although I'd have to look into exactly what the differences are there. But there's that infrastructure pod. It's mapping the ports in that we told it to map, right? So there we go. Happy. Everything is great. The other thing that's cool about this is if you've ever used Podman, it doesn't generally run a daemon. So if you reboot the machine, a container doesn't necessarily come back up along with the machine. Using systemd to manage the pod means that you can tell that pod to start up at boot time, right? Now we're going to wait just a second here until I think my VM is started back up again. We're going to log back in, and I'm going to show you that, yes, in fact, that pod came back up at boot time, which I think is also a really handy thing when you're running anything that you want to survive a reboot with, which, let's be honest, most services are. While that's rebooting, let me have a look at chat here. If anybody wants to call out whether there was a question I'm missing, please feel free. Now's a good time to do it. Is Quadlet part of systemd core? Quadlet, I believe, are packages that are installed as an add-on along with the container tools meta group. So if you do DNF install container-tools, I believe Quadlet comes along with those. So it's yes part of systemd, but it's like an add-on, right, or something. It's Quadlet is writing these unit files that systemd is then able to read. I don't think Quadlet is officially part of systemd. I'd have to look deeper into that though. Is Quadlet a server-side thing versus Podman desktop? I don't know how Quadlet and Podman desktop interact. Maybe there's someone in the chat that can talk more about that. Oh, Willie Holmes already did. Thank you. It's a Podman thing. Yep. All right, so we should be able to get back into my machine now. Oh. I could type my password for my SSH key. Okay, we're going to get back to root. And if I do a systemctl status on WordPress -pod, it should be up and running. There we go. Active, running. You see there's that output again. Let's do a Podman pod PS. Sorry. That's what I wanted to do next. There you go. The WordPress pod is up and running. Now, I did want to show you one more thing. Remember I was telling you how it would say it was degraded if one of those containers was not running? Let's just stop the DB. And then let's look at Podman pod PS again. You can see now it says degraded, number of containers 3. And that's because there's that systemd container, there's the infrastructure container, there's the WordPress app container, and the WordPress database container. There's supposed to be 4. There's only 3 running. That's why it's telling me that it's degraded. And if I just did a Podman pod start, or here, let's just do let's do a Podman pod start on WordPress. It'll just say, okay, the application's already running. I'm not going to start that up. The database should have then started again. So if I do a Podman pod PS now, it says everything's running. And just to show you, let's switch back over to my WordPress installation share. See, it's still where we left it. If I go back to just the IP address here, if I could mouse today. Mouse and keyboards, they're tough, difficult things. There we go. We're back at the WordPress installation. So you can see that the pod is in fact up and running again. The database is still working. Otherwise, it would have given me a database connection error. And there we go. So I'm going to give everyone a few folks. If you have, give everyone a few folks. That didn't come out right. I'm going to give everyone a few minutes, seconds maybe, to give me any questions that you think have come up in this particular demonstration. And if there's no questions, then I think we're going to call it a show for today. So I hope everybody has enjoyed this this little demonstration. I love using Podman for running services like this. It's really great for, you want to run some services. Maybe you don't quite have the requirements that bring you into a fully, a larger container management platform like Kubernetes or OpenShift. But maybe you might get there someday. What I like about these kube definitions is that you're already part of the way there. When you're ready to move up into OpenShift or Kubernetes, you've already got the start of these definitions. So I would love to hear about restricting user access to Podman. Just a matter of restricting access to the binary. To be honest, I don't have that off the top of my head, Eric. Maybe we'll make a future episode about that, or maybe if you hop into our Discord, we have a Discord group. Let me see if I can get the QR code for that up on the screen. QR codes, here we go. RHEL on Discord. Should show up on the screen right now. If you scan that QR code, you should be able to get over to our Discord. Maybe we can continue that conversation over there. I'd have to do a little bit of research as to how you can set up user restrictions for Podman access. I think restricting access to the binary would be one thing, but I think there's probably a more nuanced way to get that done. So disable rootless containers for users. There's Billy again. Thank you, Billy. All right, folks. Well, if there's no other questions, I think we're going to close it up for today. Thank you all for watching. Remember to like and subscribe. We do have a container lab, which walks through a bunch of this stuff as well on the RHEL online labs. I unfortunately did not grab the link beforehand. Maybe I'll throw it in the notes when I publish or post after we're done airing this episode. And with that, I want to say thanks, everybody. And yeah, we will catch you on the next episode next week. Make sure you give Scott a hard time for not being here today, or tell him how great I did. Yeah, that's probably the right way to go. All right, folks, have a great one. Thanks for watching.